this same voice. Maybe you can figure this out.
So, welcome to our lab. We're going to see two demonstrations, maybe at the same time, I don't know for sure yet. So one is going to be here with a peer 2, we call it James. And the other one was Rosie. I don't know if you all know the robots, I know a few of you were here before. The arms are actually resting on springs to compensate for the weight, and then we can use very big motors for actually moving the grippers. And like that we can basically achieve something like compliant behavior. So if it crashes, it won't destroy anything. You know, the industrial arm, like from the factory, would crash into a wall. Of course, it's resting on a spring. I don't know how many control engineers are here. It's not so easy to really dynamically move this arm, because there's going to be energy put into the spring and coming back from the spring. And then again, we don't have any force or torque sensors in this arm. So it's around 10 minutes, I think. And what we're going to do is we're going to make popcorn. So he was getting a pot from the drawer down there. And now he's getting basically the lid of the pot and a bowl which has the unpopped popcorn. And he's going to put things together, and then hopefully in the end he will serve the popcorn here. Let me talk a little bit about the perception. So basically in this demonstration, I don't know about the other picture. So you see we have these PCL stickers on the robot. This stands for Point Cloud Library, I think, right? And this is a library that basically came from our chair. And it's for working, I think, maybe in the other screen you see a 3D point cloud of the environment. And basically we are working only with a Kinect sensor in this case. And Kinect sensor gives us an RGBD cloud, so points in 3D with RGB information. And I now used it for basically all the detection algorithms here for detecting the bowl, for the pot. And there's going to be another bowl, are all working with PCL, and then basically we fit cylinders, for example, into this point cloud with a run-suck approach. And for the pot, like here you see the pot doesn't have only a cylindrical shape, it also has handles which are very important for the grasp. And then what we do is basically fit a cylinder, cut out this cylinder, and then there's some red points around there, around the cylinder, which are corresponding to the handles, and we just look for the orientation of this. Right now, in the demonstration of the P2 that you right now see, we more or less only have something where it is exactly to, for example, calculate grass poses relative to the grass. Actual grasping poses, you see, we always have the same approach. Basically, we have an approach pose, and then we have the final grasp pose. It's not very smooth, like boss complaints a lot about it, but this is basically very easy to teach. So basically on the pod, for example, we didn't actually use a grasp planner, but we would just hold the robot in a pose that would be good for grasping the pod once, and then So this is the problem now of this demonstration. I hope I can stop it now. Basically it takes 5 minutes for the popcorn to be ready. And I have to wait for that now, because as you heard, it didn't pop yet. And I don't know, you guys ready for some intro? So we'll go on with this demonstration whenever the popcorn. You see it starts already, I hope it's not taking.
Well, you guys know Rosie. This is a robot we put together, and what we will try to do today is to make sandwiches with the robot. Please understand that not everything is as robust as we would hope, so we might have to help the robot in the middle. I'm gonna start by asking the robot to make me a sandwich, okay? And it goes like this. So we have to ask the robot, right? Oh, sorry? There you go. So it's not so helpful, but you all know the command. Okay, great.
So what you will see here is the search regions, as Dwight mentioned, for perception, where to detect the hook cutting board, the bread, the toaster, and other things. And the green markers and the text labels then show the detected objects. And the perception system works in a modular way where the different modules that we I mean 3D and 2D detectors and testifiers that we developed together with, for example, Tasako Kanezaki from University of the requested object. And let's
We have one time.
and you can see that this perception routines then we find these larger search spaces into smaller ones. For example, when we look for the bread, we first detect the cutting board that you can see now. Yes. And then that defines the smaller search space for the bread. I hope you can see that the bread should be a bit different color, but they are random, so it might be all. So grasp it, and then it moves over to the toasters. And since we have a bit of localization errors, it detects stuff actually several times. So before moving into the pre-release position and then after. And what you will also see is that we also check the success for the picking up, for example, for the cheese and the salami.
The first one is a fork, and the other one is a spoon. We're gonna do the detection right now. Okay. This is that.
So we'll just continue with this here for 2 minutes, I think, as we pass through that. So that's a little bird over it. We should get it.
Okay. So right now it's looking for a little bit of minus. Okay, that you saw there, it was a bit scary. But basically, we need to produce a very fast motion for the ions to fall off. So we figured the best way was to hit the bread with the spoon. Okay. And right now, we will try to get the salami on the gripper, and it has a check to see if it worked. See, it actually uses limited amount of force. So, well, in this case, it got 2. Good. And it's going to try to put them on the bread. It actually will check if it has something in the fork after cooking it out. Okay. And when we were trying this out, we figured it was much easier for the if one hand would help the other. So that's why the left hand actually holds the things down, getting the hand out. And now it's going to search for the cheese. And it will try to grasp it. This often fails because the tool has moved. So we'll see if it manages. Okay, well, we get to see an interesting test. It actually checks now if it has anything in the hand. It will be empty. So it goes through a calibration. We'll just keep this is our calibration. Yeah. We know it's more or less how deep this is to sit on the hand and keep the skin on the thing. It's going to be a nice, strong sandwich. So it changed to see, and this time it found that it had the cheese, and then it would put it on the bread. Now the final part is to get the last piece of bread to put on top. And we'll try to grab it as well with the fork. So we didn't quite detect the closer correctly. You'll see. Luckily it searched for it again. Ah, okay. That's not right. Ah. Didn't appear. Okay, hold on. We just give it a hand now because we did it. Yeah. So we have search spaces for the little things, for the like we know the toaster should be in a certain position, and this is defined in the real world on the table. Oh. Okay. So Ingrid right now is telling it. Of the toaster, and you could find it completely. And now it's going to try to grease the bread. Okay, they got closer. Okay, so this concludes the last part of the demo, if I might interest somebody in a sandwich. Okay, thank you very much for coming, and I hope you